This is the Average Guy Network, and you have found Cyber Frontier, show number 9, recorded on September 29th, 2014. Here on Cyber Frontiers, we explore cybersecurity, big data, and the technologies that are shaping the future, all from an academic perspective. I'm your host, Jim Collison, broadcasting live from the AverageGuy.tv studios here in a kind of an evening. We've moved the time back an hour, and we post this show, of course, with world-class show notes. And this podcast always gets great show notes out at the AverageGuy.tv. If you have questions, comments, or contributions, you can contact the show. Just send me an email, Jim@theaverageguy.tv. You can find me on Twitter at @JCollison. And now, call in those questions as well. Great show to call those in on 402-478-8450, and I'll have that in the show notes, but you can go back and we'll play that right here on the show if you have them. Joining me tonight are the two guys in mission control there at University of Maryland College Park, all the way over to my right, and of course, the guy who knows everything, who started it all, Christian Johnson. Christian, how are you?
Hey, I'm doing good. This is going to be an exciting week. We have finally broken the nutshell of time and technology to put together the first iteration of the big data sandbox and development platform, which we're going to be using for all our future data analysis and interesting use cases for the show. So we're going to do a full kind of head-on look into how we built that and put that together. And it's going to cover a wide variety of technologies. So we're going to talk a lot of buzzwords, a lot of stuff, but the big thing tonight will be we're actually going to do a little bit of a deep dive. So there's going to be 3 main articles that have described this whole entire platform, and we'll finally kind of have an opportunity to get some deep dive content in the show tonight. So I'm looking forward to that, and looking forward to showcasing all the things that Ashton and I have been collaborating on since our last show.
Very cool. And speaking of Ashton, on the other side of the wall, literally on the other side of the wall, sporting some new earbuds. Yeah, knock on wall or knock on wood, sporting some new earbuds. Ashton Webster. Ashton, how are you?
I'm good. I'm excited to be across the wall from Christian doing the podcast. So we have, like Christian said, we have some exciting stuff to talk about. So let's get right into it.
Cool. Well, before we get into it, I'll say happy National Podcast Day. We got to say it here. It's actually tomorrow, which is September 30th. You're probably listening to this, except for the few we have out there live, you're probably listening to this, the recorded version. It's long gone. But the first annual National Podcast Day, and being a podcaster, and this being a podcast, I thought it was fun to celebrate. We did get a group together here in Omaha tonight, and so Dave and Ryan and Mike showed up for that. The 4 of us, 4 podcasters here in the Omaha area, got together for a few drinks and a little appetizers. And so, guys, I want to say thanks. They said they would try and get out here and listen to tonight, and so if you're listening out there, thanks for coming out. All right, Christian, let's dive in. I know you guys have been working hard on kind of bringing Cyber Frontier Labs up to speed, and a lot of, in fact, if you're listening live, or even if you're listening to the recorded version and you're not driving, but you're somewhere where you can look it up, you might want to head out right now, Cyber Frontier, no S, Cyber Frontier Labs with an S.com, and a lot of the stuff we're going to talk about is going to be out there. I'll post that in the show notes or in the chat here real quick, so if you guys have that. But Christian, get us started.
Sure. So and part of the whole point of what we're trying to do on Cyber Frontier Labs is not just provide the content for the show in some regards, but if you're someone who is, already in the field of cybersecurity or big data and is looking for some interesting test cases, or you're a beginner and you're trying to break into it for the first time and figure out where to start with, how to get involved with tinkering with the technologies, that's really where Cyber Frontier Labs is going to condense that all into written instructions that you can follow and provide some commentary, and then hopefully these shows on top will give you what you need to get from start to end. And of course, if you always have questions, try and actually call those in, and we can modify the white paper accordingly, so to speak. So there's going to be 3 articles we go through tonight. The first one is going to be talking about how we actually design the platform that we're going to do all of our Cyber Frontier Labs experiments on. So one of the great advantages of being at the University of Maryland and having the network that we do is that I can set up a box and give it some kicking fiber internet into the machine and really have that accessible. And so Ashton and I have been working on building that machine so that we can deploy the latest and greatest in what Apache has been offering in the big data space. So looking at the new version of Hadoop 2.5, which I have to imagine very, very, very few people, less than 0.1%, are running in production at this point. And we're really going to look at all the kind of standard technologies with big data and their newest iterations and start talking about some of the new stuff that we're going to be doing to do analysis on some of the data sets that we're going to bring into this. But before we can do that, we have to actually talk about, well, what is it that we actually built for the lab? So in the article, which you can find either in the show notes if you're listening to the recorded version or in live chat, just follow from cyberfrontierlabs.com and start from the post called Creating a Self-Contained Big Data Development Sandbox, and then we're going to work our way up to the top of the homepage. So the first thing, I want to talk about the hardware. The requirements that I wanted was, Ashton and I are both at the University of Maryland. We kind of wanted a system that if we had to pick it up and move it to a completely different location overnight, we could do so and be able to do it without having to change how the system runs, the configuration, etc. So the first design requirement that I kind of stipulated was I wanted something that performed relatively well and emulated a truly multi-node cluster like you would see in a data center for Hadoop, but have it all be on one single box. So I took a 1U server off of eBay, which cost me about $200. So at that price point, we're talking pretty cheap, right? And that comes with, dual socket Xeon quad cores, 16 gigs of RAM, 4 10K SAS drives, and 2 1 gigabit NIC ports. So for people who like to talk hardware, that's really not a bad deal for $200. And that's the advantage. Everything is self-contained in that one box, and it's running a multi-node virtual environment that's comprised of 4 virtual machines. A lot of people would probably argue that, why not just spin up 4 VMs on AWS and be done with it? And to those people, I'd say that's a perfectly valid approach. I just wanted to have something on my own hardware and kind of put my own thing together that was tweaked the way I wanted it. And the advantages of this is there's going to be some trade-offs, right? So on the one side, the hard drives, you get in a 1U machine, you get 4 drive bays. So how do we maximize that in the most efficient manner so that we can pick up some, relatively sized hard drives that can store big data sets or test data sets and also kind of mimic the performance we would see in a multi-node environment. And at the surface of that, the first answer is to say, well, let's replace all the 4U drives with 3 terabyte drives. And the market is definitely suggesting to us that the price point for hard drives right now is to buy 3 terabyte hard drives, because for $100 a pop you can pick up a 3 terabyte drive, and that's a very low cost in comparison to what it is when you jump up to 4 terabytes or drop down to 2. So one solution to that is to say if you have an extra $300 or $400 to spare on the platform, you pick up 4 3 terabyte drives and you throw it in there. In my case, I didn't feel like doing that because I had 2 perfectly good 1.5 terabyte drives that were sitting around lonely without a home. So what I decided to do in this particular setup for this environment was to take the first 2 hard drive bays and leave them with the SAS drives that came with the machine and RAID those to have a fast boot partition. And the second 2 drives are RAIDed together to basically make a 3 terabyte storage array. A lot of people who are familiar with the big data space are going to raise their hand and say, oh, but Hadoop runs faster if it's just a bunch of disks, and all those just a bunch of disks are connected to HDFS via their data nodes. That would be the recommended approach if you, in fact, went out and bought 3 of those 4 of those 3 terabyte drives and put 1 VM image on each drive, so to speak. But in our case, we set a replication factor of 1 on HDFS, and we also are backing up those files. So there will be a slight performance degradation by using RAID, but it's not anything that's going to kill you. And in a development platform like this, it really kind of becomes inconsequential. But we pick up for that performance lacking by having some really cool features of virtualization that you aren't going to get in the enterprise. So in order to actually, how do we create a multi-node environment within a single box? Obviously, the answer to that is virtualization. And most people are going to say, may or may not cringe when I say the word Microsoft on a show about big data and cybersecurity where it's dominated by Unix. But I decided that I was going to use Microsoft Hyper-V 2012 R2 to run all of the Linux VMs. So Jim is really excited about that. We promote that as a technology of choice elsewhere, and it's really great software. I mean, whether you're talking the average guy or whether you're talking enterprise virtualization, Hyper-V 2012 R2 has really come a long way, and it makes it super easy to do it. So if I don't have to screw around with KVM or QEMU in Linux, I'll take that. So I went ahead and installed Hyper 2012 R2 on those first 2 SAS drives. And the goal here is you want to set up a private data network that allows data to be exchanged between the HDFS partitions as quickly as possible. And you want to have kind of a management interface that allows you from anywhere in the world to securely SSH into the big data network, development network, and access all those machines. So I actually did a very interesting thing. The average guy running Hyper-V probably is going to think I'm weird. It's okay. We'll get over it. But the easiest way to actually set this up is to build one virtual machine that runs Linux, and it acts as a router. So you basically, in my setup, in my tutorial, you'll learn the basics of how you build your own Linux router within Hyper-V. And what that lets me do is I have 2 physical NICs on that 1U box. So I dedicated the first physical NIC to the physical Windows operating system that's running Hyper-V. But the second NIC is dedicated to one of the VMs that I'm running, which is the virtual router that I'm creating. So it almost acts as the WAN port for that virtual router. And that's what allows me to use passwordless SSH to get into my system. It also is what enables the router to act as a gateway on the private data network so that the individual data VMs can get out to the internet, get updates, etc. What's really great about this is that the performance is top-notch, because one of the cool things with Hyper-V is that when you create what's called a private virtual switch, all of those machines are directly in a private network that's being emulated by the CPU itself. So there's actually no physical network bus, so to speak. It's a virtualized network bus, and therefore your data transfer rates over that network are going to be incredibly fast, far faster than what you would get if you have a bunch of data nodes running on like a 1 gigabit switch, for example. So that's where we see a big performance advantage in doing this kind of setup. And the article explains that, so I'm not going to go too much deeper in there. But other than to say it's really nice having Hyper-V. It just kind of makes things easy to do and work with. And the other nice thing was, once you have Hyper-V, a lot of, I guess, kind of the Hyper-V of yesteryear, particularly in kind of the 2008 era of the technology, one of the big problems was trying to get guest integration drivers for Linux operating systems. But now the new CentOS 7 distribution, which has been released to the public, I would say about a month ago, has those hypervisor drivers natively built into the kernel. So you're up and ready to go right out of the bat. And CentOS is one of the official supported operating systems for all the Hadoop technology. So that was kind of a win-win situation for us. And when you're building that virtual router, really the magic behind the curtain, so to speak, is only one thing, and that's IP tables. And IP tables is, where you're going to define all your NAT rules, all your port forwarding rules, and define all the access rules so that you can more or less do everything kind of manually. So hopefully you're a geek. And manually put in all those rules, save your IP tables, and now you kind of have complete control. You have a gateway, you have the ability to access and forward ports to a publicly routable IP address, and you can
hopefully not lock yourself out.
Yeah, and hopefully not lock yourself out. Otherwise, it's a trip to the data center. Like I said, for $200 to emulate 4 virtual nodes and have a what we would call a Hadoop master node with 2 slave nodes, and have the performance on that machine, which is 2 dual socket Xeon quad cores for, it was $200 for me to put all this together, and by doing so, we can test pretty much any modern Apache data platform or big data ecosystem that's out there, and that's really what this particular setup focuses on, is how do we get something that performs relatively well? It may not be the enterprise that everyone would demand on a real scale, but gives us all the flexibility to run tests, to create applications, and then when we do get that deep thought to compute license to put it on 10,000 nodes, it runs like a charm, and that's really the inspiration behind that.
Christian,
sorry.
One sec, Ashton, real quick. Where did you physically put this box, Christian?
Yeah, so this box is actually physically running in a secret undetermined lab that has fiber connections into it. So it will it's Speedy Gonzalez. It's about 1 gigabit out, and it's a development rack that I have access to. So it was a great home for it, and it also takes care of the little issue with the setup, which is this thing is really loud if you put it in the basement of your house. So unless you plan to soundproof one of those 1U servers, make sure you have a nice place to put it where it's not going to bug you.
You'd think they could make those little fans a little quieter.
Yeah,
they're loud. They are loud.
Yeah,
Christian was telling me that he had it in his basement, and it was so loud that they couldn't sleep because the fan was just...
Yeah, those little
really
fans.
loud.
We had an HP version of this at the meetup last week in Indianapolis, and if you turn that thing on without the lid on it, it's even worse, right? And so it's just pretty loud. Christian, do we need to thank the venture capitalist that's behind the funding of this?
Yeah, well, as all things, we thank Gary Johnson for his just innate abilities to find things on eBay at the most opportune moments, and then
he should go into business and resell that stuff. He finds some good deals.
Yes, and then just very, very gently pry the hardware away from Buffalo and move it downstate with the vehicle. So he's always a honorary member of the development platform for these.
It's good.
For these
Thank you, Gary, for your contribution to Christian's education.
For sure. So once we had that development box up, which I would say, given my time, it probably took me 3 or 4 days to do that. So to get Hyper-V running, to get the management up, to get the new hard drives installed, to bring up the box, install CentOS 7 on all those VMs, run updates on all of them, put them all on that private network, get them routable, and then set up secure SSH. And so that's kind of part 1 of what makes the data platform. Part 2 is, well, we need what is going to be the fundamental technology that drives us being able to analyze and take a look at big data or just data sets in general. And that's going to be for us HDFS, more particularly Hadoop 2.5.1. But Ashton and I are going to actually be looking at a lot of technologies that build on top of the Hadoop stack. So really, Hadoop is kind of it's almost a misnomer in the sense that all we really want out of Hadoop is HDFS, and then we're going to be putting other applications on top like Apache Spark, where we're going to be doing the actual analytics and talking about that. And we'll get to that tonight when we talk about what HBase is and how that actually works. But you have to have
some of the other applications also use Hadoop in the underlying kind of like lower level calls that they do, but they build up on top of it, which is kind of why I think of Hadoop or the HDFS really. I think of kind of like the bread and butter, and then you can actually like make it a meal with these other applications that you plug into it. So.
Yeah, exactly, and it's kind of like you go to Boston Market and you pick a meat and 2 sides and cornbread, right? So the meat is Hadoop with HDFS. Your sides are like HBase and Spark, and then cornbread is I don't know.
There's definitely an analogy there somewhere.
It's there.
The cereal behind you, Ashton. Maybe.
Yeah.
Yeah, it's like the milk, and then you add your cereal. You can mix and match. It works for any metaphor.
Nice.
Yeah.
For sure. So the reality of it is that if you've never installed Hadoop before, I would say like on a scale of 1 to 10 of how difficult the installation is, if it's your first time, I would say maybe a 6. Is that a fair assessment, Ashton?
Well, it's not as bad as it was. It's definitely not as bad as it was. Because I remember when we did it like a year ago, with 2.0 maybe.
Yeah, it would have been 2.2, 2.0.
2.2. It was like just dependency hunting for like hours on end. This
Right.
one built pretty cleanly once we figured out that it needed protobuffer from Google.
Yeah, protobuf. Yeah.
But once we had that, Maven handled all the dependencies. There wasn't really too much to do there. So.
Yeah, and just to put that into context, one of the things that made Hadoop so hard to install when it, first came out a couple years ago is that it didn't have a Maven file, which Maven is basically what it looks at an application source code and it finds all the dependencies and installs them on the machine automatically. All you have to do is sit there and watch pretty text fly across the screen. But that wasn't the case a couple years ago, and you ended up having to basically manually go through and see, oh, this error message means it didn't have this dependency. And I spent on my first Hadoop install of like Hadoop 1.1, I think, I must have spent at least 6 hours doing dependency hunting, and it gets frustrating because it's like if you don't have the right point release, it just breaks, and then you have to revert it, and then you don't know where the path is, so it's just a headache. But with Hadoop 2.51, we're really starting to see Hadoop become enterprise software in the sense that it's like, we're almost there where it's a click of a button and you're in the run state. I would have to say Hadoop 2.5 has installed easier than any other Hadoop I've done. Still, if it's your first time, though, you're probably gonna learn some things, and it'll be a little bit rocky. But if you follow my guide on Cyber Frontiers and others, you'll pick up what's going on.
Yeah, and there's not like a huge amount of documentation for 2.5. I don't know that we found anything for 2.5 actually. We found a lot of stuff for 2.x releases, and that can make it a little daunting because you aren't sure exactly if that's going to apply to the newest version.
Sure, and to be fair, I think we're probably one of the first people talking about Hadoop 2.5 specifically. It's very similar to Hadoop 2.4, so most of those articles will get you through. But my disclosure on all things installing Hadoop is that any guide you find out on the internet is a cliff notes. It is not like do this, do this, do this, and you'll get to here. Anyone who writes that, including myself, tries to make it that way as much as possible, but slight changes in your configuration can really just change the way the installation happens. And you'll figure it out eventually. The screen will tell you something intelligent, and you'll use deductive reasoning to get from point A to point B, hopefully. So that's really what these guides are intended to do. So my Hadoop 2.5.1 guide is talking about CentOS 7, so we're on the latest operating system. It'll take you through kind of the basics, right? So how do we set up passwordless SSH? How do we install Oracle Java instead of the native OpenJDK? How do we do host entries on the machine? How do we download and compile Hadoop from source? And that will actually take you through getting the Maven set up so that it will automatically go and get all those dependencies and compile it. How do we then set up the environment variables for Hadoop and put the name nodes and the data nodes online, set the correct permissions, etc. And once you get through all of that, you're really in a pretty good spot to then you get to the point where if you get through that experience, when you want to start a Hadoop cluster, it's just you type in start-dfs.sh and the whole thing comes online. So eventually you do get it down to that one click. It's just getting that initial install to take is what you have to look out for. So really the big takeaway from part 2 of the article, I don't want to get too much into semantics because it's really just reading XML files, and we could do a demo at some point, but I don't think it's really productive to your time. So go out and read that first, and then if you have questions about it, go ahead and give us a call or leave us a shout on the post itself. And then the third part is, like I said, so we installed the chicken. Now we got to get the two sides, the green beans and the mashed potatoes, or the stuffing. I'm not sure which. So Ashton, once I got Hadoop installed and I got this infrastructure, Ashton basically took over and brought on top HBase. So why don't you go ahead and at least first tell us what HBase and Zookeeper are, and then how we're going to use it, how we set it up, and how it interacts with Hadoop itself.
Yeah, so the analogy, well, the explanation that I have in the article is basically along the lines of this. So you have HDFS set up, which is great, and you have I mean, it's excellent for distributed files, which is perfect, which is probably what you need. But if you have, let's say, temperature data, you've been tracking temperature from sensors all over the place, and you want to figure out on Tuesdays what's the average temperature in the year 2012. How easy it is to get that information depends heavily on how you're storing it. So if it's stored in a nice database, and you've got the field set up so that you can, and it's indexed on the time, it can be really easy to get that. It can be one query away, and you have that information. If it's not structured well and it's just in files in the original format that you collected it in, maybe tab separated or comma separated values like that, it can be a real hassle, and maybe you need to start to use some Hadoop jobs or some scripting to try and figure out where the information you need is. So what HBase does is hopefully it puts you in the former situation where it's nicely structured and it's in a database. Because essentially what HBase is it's a NoSQL database that sits on top of HDFS. Where Zookeeper fits into this is it provides a way of synchronizing this HBase application and other applications like it that need to deal with a lot of the same issues in terms of distributed applications. Like they all have similar issues with deadlock and race conditions, and just having data accessed at multiple points at the same time can cause a lot of the same issues. So Zookeeper kind of provides an interface for these applications to work well regardless of their type. And that's kind of a prerequisite to get HBase working. So that's what I walked through first. It's not a super complicated install. You just they have binary distributions that worked for CentOS. I believe there are source distributions as well. And using the newest version, or newest stable version, which I believe was 3.4.6, it worked pretty well out of the box, so that was a good start. And then you essentially install HBase, and from there you can start to insert your data and query it, and I do a little crash course in that at the end of the article. So if that sounds interesting to you, go ahead and read it. It's really helpful for just adding a database interface to a Hadoop and HDFS, because otherwise it's very likely that even though you have this big data platform, you don't have a good way of accessing the data that is stored on it. And there's a lot of projects that I already have in mind where this is going to be really useful for structuring the data and making it easy to get to. So, sorry, go ahead.
No, I was just going to say, so can you, I think we got it mostly, but I just wanted to kind of emphasize the point that HBase is not only is it a NoSQL database, but so the tables, it's a little bit different from another package that you may or may not be familiar with called Hive. And Hive is actually basically another add-on to HDFS that allows you to write direct SQL statements, almost as if you never left Microsoft SQL world. So that's actually a pretty cool technology. This is cool because it gives you another way of having a NoSQL relationship like you would see in a MongoDB database, and lets you and HBase basically stores its back-end data straight to HDFS. So it's still taking advantage of that distributed data environment where file blocks and block allocations are being distributed throughout your cluster, which is what gives HBase the same type of performance characteristics as your typical MapReduce operations. And at the end of the day, I'm pretty sure for Hive was basically when you created and wrote a SQL query in Hive, it actually translated that to a MapReduce query. I'm not sure if that's the similar type of behavior with HBase, or if it's just storing its own database operations within HDFS. But that's kind of the underlying architecture that's feeding that whole thing.
Yeah, and also it provides a nice interface for a lot of scripting languages. I know Ruby especially, it has the shell is built off of that, so it makes it easier to do these quick scripted operations to get the information that you're looking for. And like you said, there's other options with Hive, and it depends on whether you're looking for a SQL relationship or a NoSQL relationship. But if you are looking for a NoSQL relationship, then HBase fits the bill pretty well. And one of the interesting things which Christian kind of touched on is that where it does still use that HDFS backend. It's not just storing this. It's not like a separate application. So that's why we're saying this is one of the things that plugs into it. And I don't know if you can see Christian's screen right now, but he has the Hadoop. Is that HBase or Hadoop?
Right. So this one is Hadoop, and I wanna kind of cover both screens because I think it kind of tells you what's going on, sort of. So this is the overview page of the Hadoop cluster in operation. So we can see that I started the cluster on this Friday. It's running the latest 2.5.1. And if we take a look at the summary, we can see that it has 98 file blocks in there, which basically means I'm storing hardly anything in HDFS. Notice our configured capacity is 2.42 terabytes. So I would say when we rated those two drives together, I think the total formatted space was 2.7, and some of that obviously gets recycled back into running the operating system for the virtual machine, so 2.42 is a pretty good number. And you can see, hey, we still have 0% usage, 99.93% left to go, so we're going to be filling that up pretty quickly. Notice, though, if I click Live Nodes, you can see what I'm talking about with the kind of internal data network. So you can see these are the three virtual nodes that are running our Hadoop sandbox. This is the master node at the private 10.10.8.2 address, and you can see it's in service. It's contributing to the HDFS cluster. Here's the number of blocks that particular cluster is storing, and we can see, okay, there's no failed volumes, and everyone's on the same version. Great, we're good to go. Did you have something you wanted to add?
I did have something. I actually had a question for you because I'm not sure how we did this, but I found it interesting. So those are the private network that sits kind of behind this one public-facing router that we have, and that's good for a lot of reasons. I mean, one, like we said, this is running on the same. This is all on one piece of hardware. So those are sort of is a kind of a virtual network. I don't know if that's the correct term for it.
It is. That's exactly what it is. It's a virtual network.
They're all on the same machine. These are just the VMs with their assigned IP addresses communicating with each other. And because they're on the same machine, like Christian said before, it's exceptionally fast. So that's a plus.
Christian, can you zoom in a little bit on that? I'm sorry, Ash.
Sure.
Just see if Christian can zoom in. Keep going. There you go. Perfect.
Yeah. Right.
Yeah. So I just want to ask Christian, because I actually don't know how he did this, how he got those set up behind one. So one VM acts as the router, and the other three
exactly
act as the private network.
Right.
Do you want to elaborate on like how you did that? Because I'm not even sure, and I helped you set it up.
Sure. So this is where having a little bit of experience with another buzzword, but an important word in my life, OpenStack, comes into play, because I've been, for the last I would say fairly 6 to 8 months, my brain has been just completely engulfed in software-defined networking, creating virtual networks, and how you do all that. So one of the things I've picked up working as a research, working on research for NSF with this stuff is there's a lot of different intuitive ways you can do this, and IPv4 and taking advantage of network address translation is really the first big thing. But let me try and put this in perspective, and maybe I'll make sense, and maybe I won't, and I'll have to do this again. So
that's all we can ask.
Yeah, so think of the three nodes that make the sandbox as regular computers on your network. And think of those three regular computers on your network connected to like a Netgear or a D-Link router at 192.168.1.1, right? The famous home network router address. That's basically the environment I've recreated here, but you have to kind of take all that physical stuff and push it down in the virtual space. So how do we do that? I'll try and diagram this out audibly, and hopefully you can follow. So somewhere in my magical secret dev lab, there exists a line that comes into the development lab that gives me maybe a block of, let's say, 30 public IPv4 addresses. So think of me as I'm Mr. Verizon Files, and I'm coming to hook up internet in your house. So I take one of those public IPs and I plug it into your ONT in the basement, and great, you now have access to the internet, right? but your computers aren't all directly plugged into that ONT, right? Verizon Fios, they give you a router, and that Verizon Fios router takes the public IP address from your ONT and uses it as its WAN IP to give internet access to your inner machines. So I replicate this by treating, there's 2 physical NICs on the 1U server. That first NIC basically is that WAN cord coming in with a public IP address that can be taken. And then that just gets assigned directly to an interface in the Linux virtual machine. So just like if I were to take a laptop and plug directly into the ONT, my laptop would get assigned that public IP address and my computer would be out on the internet and fully accessible, right? That's the same thing that's happening here. But the magic happens when I use IP tables. And IP tables is a very sophisticated but simple program that lets you do all the network address translation and anything that would be what a router would do, you write in IP tables. So the first thing I do and let me finish the physical path first, right? So you have this physical WAN port that has the IP that the Hyper-V software is basically letting that virtual machine directly attach itself to that Ethernet port. So it's almost like that machine has exclusive access to that Ethernet port as if it were a physical machine plugged in itself. Then it has a second interface on that virtual router, and that's the interface that is looking at the private network that we created in Hyper-V. So that's like having your home LAN network where you have a switch and you have 192.168.2 is your desktop, .3 is your iPad, and .4 is your telephone. Well, I guess we would call it mobile. Anyway, smartphone. Anyway, so what we're doing here is we have these 2 interfaces, public, LAN, and we have to say, how do we get communication to talk between the 2? And that's what IP tables is doing. So let's say I'm a computer inside this private virtual LAN that Hyper-V creates for me, very simply with that switch manager, and I want to get out to the internet. So my, let's say I'm the data node, I'm a data node 2, and my interface, just like I would in my home network, I have an IP address like 10.2, 10.10.8.2, and my gateway is at .1, right? So it's going to send a packet for google.com to the .1 address. And that virtual router that I created has a rule in IP tables that says if you see this private address requesting a public address, redirect it using network address translation to my public interface and send it out to Google. And then that packet is received by Google. Then Google says, I'm going to send that packet back to the virtual router because that's the person who requested the resource. And then the virtual router sees, oh, this was something that I originally rewrote for this client, so it's going to re-change the header again, and then it gets sent back. That's
all done through IP tables?
Yeah, it's all done through IP tables, right?
The only thing I've ever been able to do with IP tables is lock myself out of computers, so I'm
Yeah.
impressed by that.
Yeah, so IP tables is a really powerful tool. A lot of people, when they're first starting out with Linux or network administration, just think that IP tables is about allowing ports, blocking ports, and traffic.
Firewall.
But IP tables, yeah, it's a firewall, right? And that's one of the core functions people use it for on average, but it also can act as a very powerful router, and it has anything that you can do with network translation, and it lets you basically manipulate the packets in the network itself. So I can rewrite source headers, I can rewrite destination headers, I can do something called packet mangle, which actually takes the whole address and throws it out at another computer and just basically sends traffic without verifying it comes back. There's all sorts of things you can do with IP tables, and basically anything you're and really what's happening, so here's another little story. When a lot of people install things like ddwirt firmware on their router because they want to have that customized thing, what is ddwirt really doing? All it is a Linux kernel that is running IP tables. So all of those OpenTomato, ddwirts, etc., it's literally a Linux kernel plus IP tables. And all that graphical interface, like pfSense, for example, pfSense is basically a glorified IP tables where when you click a little button in pfSense and you click save or you port forward, all the GUI is doing is taking that information you put into the form and it's writing IP table rules and saving it. So it's magical, really.
I think that's what a lot of like even command line level scripts do, like UFW for Ubuntu.
Right.
It just modifies IP tables, so that seems to be the underlying low-level system that handles all this stuff anyway.
Right, and really the message here is that you want that private data network where it's virtualized so that there's no overhead and the nodes are basically talking directly to each other without issue. And you also want it so that you wouldn't want your master Hadoop node to have a public IP address because Hadoop has so many ports it opens up. If you get port scanned by a bot or something, they're going to find like 50 ports open and they're going to start going boom, 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 and you're like, well, I don't want this. The really cool thing about that router, like I said, is that that router, not only is it acting as like an internet gateway just like you would, but say you're at home and you want to forward, I don't know, subsonic out to the internet on a particular port, we do the same thing. This information page that we have screen shared right now, that is using port forwarding to basically, you hit the public IP address and it rewrites that port to what the private master node is at this 10.10.8.2 address, which is a privately routable address only. So it's a really cool way to do it, and it helps you think about network architecture, which is always really important, is especially a lot of the stuff I've been looking at is how we use HPC and high-performance networking resources to transport large quantities of data and workflows to these applications like Hadoop. And one of the big things about OpenStack is everything is virtualized in OpenStack, right? So that is where you start to see a newer topic called software-defined networking, where everything exists in virtual lands, everything is bridged so many times you don't actually it takes weeks and months of actually studying these diagrams to understand how you architect all of this virtual layers, and that's the direction we're heading in as a just as a cloud infrastructure, as a big data development infrastructure. We're heading towards an era where our entire networks are virtualized, and the only thing that is physical is layer one, which is you plug the cable in and it has a physical route from point A to point B, and everything else on top of that is becoming software abstraction. So we are now abstracting what was once the physical components itself, and that is starting to really change the whole ground for how we're doing data processing in general and cloud computing. But to kind of bring it back to what we're doing here, this isn't really in the SDN space. Yes, it's virtualized, but we're using the same old tricks: IPv4, network address translation, and Hyper-V to make all the virtualization magic happen.
And now more than ever, you do not want to have these kind of embedded web server type things sitting out with ShellShock. They'll just hit up those CGI
definitely
scripts, and it'll really screw you up. So it's good that when you have this, like, I mean, it's kind of built into most networks anyway with the NAT translation. That's redundant, but NAT will be the point where the traffic actually is connected to the internet, and that blocks a lot of the stuff behind the scenes that you don't want to be public.
Yeah, definitely. And one of the big takeaways from this past week, so I think it would be negligent of us to not at least say, let's all say the word ShellShock so that we have added ourselves to the millions of other people on Twitter talking about it, right? But why is ShellShock such a big deal? And it really boils down to a very simple fact. It impacts just as many people, if not more people, than what Heartbleed did, right? And so I think now we're measuring how bad an exploit is, and reasonably so, by how many people it impacts. There are so many embedded systems that run that bash shell with the flaw in it. I don't really think embedded systems are, they're not going to be at risk. What's going to be at risk is, and we saw this happen as soon as the vulnerability was published, we saw some very interesting things happen in the hacker community. Number one, the Metasploit developers wrote 4 modules to take advantage of ShellShock. So you basically had everything script kiddied and ready to go for you already. And then number 2, everyone started scanning the entire IPv4 public space, because the big area where ShellShock has an impact is for web servers that are running Apache and are running Bash. And you can actually basically put crap in your HTTP headers, and that's getting interpreted by the environment bash shell. And that is just, you look at that and you say, shame on Apache for developing the way they did, and shame on Bash, obviously, but it's really, that's where the problem is for, this is a nightmare for shared web hosting, private web hosting. As soon as this came out, I logged into my machines in a second and had to update it, because I was a prime candidate for being vulnerable to something like ShellShock. I was running public websites in a shared virtual host space, running Apache and Bash and CentOS. So I'm
You're not particularly unique in doing that. I mean, that seems to be almost the default. I know in a lot of cases Bash is the default shell.
Right.
And when you think web server is almost synonymous with Apache for a lot of people, so it's a very common thing. So
yeah, no kidding.
And more than that, it's been there for, it's not like Heartbleed, which was introduced, I believe, not too long ago, and they could check out the source, and they were like, oh, this is when it was introduced, and it went unnoticed for a while. I was reading an article that said this has been in the code since sometime in 1990s.
Yep. Yeah.
So it's like, I mean, 20 years old code that just it kind of had this illusion that, oh yeah, a lot of people are looking at it. It's open source. But it still wasn't caught, and that's the scary thing about it. It's like it could have been exploited, and you would have never known until now.
Yeah. So the two strikes are kind of the following. Strike one is, it's been here since the 90s, folks. Ooh, that hurts. But that really wasn't going to be exploited at the level of concern that I'm talking about until.
Until now.
We need to study where it was that this happened. But at some point, when Apache got so far in its development and was integrated in that environment shell where you could pass the crap in through the HTTP headers, that's where the problem happens on a very big scale. So we need to find out when that actually happened, and I don't think a source code analysis of Apache has been finished on that yet. I'm assuming there's people out there doing it, but that's just kind of the zinger. So if you have any kind of machine that says like Linux or like CentOS or just anything that runs a non-Windows logo, I would run like a yum update bash or like a app-get install bash and make sure that that's patched. Chances are, if you are running anything that's public-facing, you've already done this, so this is a moot point. But just do the patch. Pretty much everyone released a patch within a day or two. So I guess out in chat, a good point is brought up. Everyone thinks that oh, the Linux kernel, it's more secure than Windows, and but the reality is, I think the next 3 to 5 years, we're going to start to see more Heartbleeds, more ShellShocks, and it's interesting too because I think we're starting to see these happen much more frequently than what we were in like 2007, 2008. I think that, I don't know, maybe it's just me and when I got involved in this stuff, but the first big thing that I kind of remember being not affecting the masses, but being a big news story was when Stuxnet took out the nuclear facility in Iran, and ever since then, it seems like slowly we've had more visibility in these issues, but now, like in this post-Snowden, post-OpenSSL, post-ShellShock, I feel like this is starting to snowball in a way that is pretty serious and making us starting to realize that we cannot just develop really fast and put a bunch of stuff out, which is what the open source community has been doing as best as they can and with the proper testing and so forth. All that is taken with sincerity, but the reality is we have a lot of work to do to start going back and patching up these legacy systems. And going forward, we have a lot to do to start ensuring we write stuff that represents, hey guys, we're in the 21st century, we should act like it. And what do I mean by that? I mean, why do we keep doing design? We make interesting design decisions. Like, for example, and I do the same thing. How many scripts have we developed in the last 2 years that use epoch time in Unix to calculate time offsets? Well, by 2038, all of those scripts are going to be completely invalid because the integer size won't be able to store the 2038 in number of seconds. And it's the same thing as what Y2K was, right? But the same type of logic and rationale applies to the security issues that we're seeing in this development, and so it's just critical. And so even though we're talking about big data development platform, and I completely sidetracked from that, but it was all relevant to this idea of building a network. Even when doing development stuff like this, I'm extremely precautious that I know how it is I'm getting in this system. The people who are developing with me know how to get in this system, and no one else does. And I patch that and clean that to the best of my ability and take these precautions and do smart things, right? Like building that virtual router that acts as a shield for that network. That's a smart thing to do, right? But at the end of the day, if there's a shell shock and I don't know about it, then there's a shell shock that I don't know about, right? So that's kind of the reality we face. I just wanted to pull up one more screenshot really quick because this is the fruits of Ashton's labor. This is the Apache HBase console. So just like we had one for Hadoop, we have one for HBase. And so we can see some cool things here, right? And some also interesting flaws. So I'm curious to see what HBase was thinking here, right? We can see HBase, here's the version, right?
Not the correct Hadoop version.
Right. So why did it pick up Hadoop 2.2?
I can tell you why it did that.
All right, go for it.
There is not currently an HBase distribution for Hadoop 2.5.
Okay, so it's seeing the most recent.
So,
right.
and actually, I made the mistake of getting the wrong Hadoop version the first time, in that it was like 1 point something, and that was a irritating issue I had to fix. But 2.2 appears to work with 2.5. I'm not sure what kind of issues it's going to produce, but as of now, it appears to be working.
Yeah, I'm pretty sure
so
that's why. They're pretty backwards compatible, is my guess, to be upfront there.
And since
yeah, go ahead.
Since we were talking about ShellShock, and I can actually think of a pretty nice way to tie those together with what why I made this. Well, part of the reason why we made this in the first place. I don't know, Christian, if you want to go into kind of like what the purpose of it was.
Yeah.
So one of the things that we had in mind for this was to start kind of scanning all of the IP addresses and storing the information that we had found in HDFS. And HBase was the way that I had in mind for storing this information, and then using something like mass_scan or nmap to get the scan data. So in probably next post or the one after that, I'm gonna probably do one on going into detail how that scanning process works. And now that there's the ShellShock component, and there's a lot of I was actually reading an article about how mass_scan can be used to detect ShellShock vulnerabilities. That would be probably a good thing to track, is what percent of the ones that we scan have this vulnerability. And how prevalent is this? And I would imagine, from what we've heard so far, very, very prevalent.
Yeah, for sure.
So that's kind of what motivated, one of the things that we could use this for, and one of the purposes for it. And that's just one example. But the actual implementation of that should be something that we read about in the coming weeks. So I'm excited about that. I already have kind of the scanning thing set up. And the translation into the format that can be inserted into HBase, so it's all coming together, and it should be a pretty cool thing in the coming weeks.
So just to be clear, what all that was is we are officially announcing, as of this point forward, Cyber Frontier Labs, #1, is in full operation and has all the tools it needs to do, and #2, we will begin this week scanning the entire World Wide Web IPv4 address space. It sounds really awesome, but the reality is a ton of researchers have done this before. I'm sure many people listening to this know this to be the case, but our whole point in doing this kind of experiment, so to speak, again, is to show how these big data technologies and these newer evolutions have improved over what types of analysis and data analytics and data science you can do with these platforms. So we're really looking forward to showing you things like, hey, how can you build the HBase table that shows you which IPv4 addresses on the World Wide Web have a ShellShock vulnerability? How valuable is that to the research community to have an understanding and an optics of that? So this is where this podcast is heading. This is where the labs is heading. We're now going to actually start demonstrating not just how you build and set up the technologies, or talking about what's going on with them in relation to the whole community, but now we're going to do some actual, here's a real world case. ShellShock is out there. can we, and it's going to be a proof of concept for how good we are at this stuff too, right? So we'll put some money in our own mouths. Can we tell you, using these technologies, how many IP addresses on the World Wide Web are currently vulnerable with ShellShock? That's a pretty cool thing to be able to do with something like Hadoop, which is open source, and I can put together all these tools. And if I log on to cyberfrontierlabs.com and build a similar platform myself, I myself could build these data sets. And if we get really, really good at this, we actually might be able to publicize some of those data sets and make clean, sanitized data sets that you can then import into your own analytics and do whatever you want with. So, you know, this is heading towards a pretty cool direction, and it's great we've made it at this stage.
Yeah, and you've talked a little bit about the research components, with which I am all for, because having done some research with the University of Maryland, the two things you mentioned: one, clean data sets, very, very hard to come by. Second thing, the storage of them is oftentimes very haphazard, and they're almost never stored in databases, which I hate, because it just makes it the structure is never predefined. You don't know what exactly the file name is going to be, if that's the way you're storing it, or how is the file hierarchy going to be set up. So that just makes it 10 times more complicated. And that's just the research component. If you're looking at this from the enterprise perspective, then there's a lot of potential to do prototyping on a scale like this. So maybe you want to see if something works. You can set up this box that we have for, you know, we did it for $200. I mean, I'm sure that if you wanted to do something comparable, it's not a super expensive task to get it set up. And also, hopefully, it'll provide some insight for enterprise, like what you can use this for, especially for companies that are potentially in cybersecurity or other fields where distributed file systems and the analysis that they can have is really important.
Yeah, and I think, you know, one of the other big things that you'll take away by, you know, doing this yourself is you realize we aren't just talking exclusively big data, or exclusively, wow, I just said big data, or exclusively.
Okay, Boston.
Yeah, or exclusively cybersecurity. But you can see just in setting up the platform, there was a wide range of technologies that would cover things like network administration, IP tables, things that are really applicable in other areas that have nothing to do with big data, that will kind of help you understand the ecosystem better. So, you know, I almost feel like we should end each show with a segment like Jimmy Fallon would, we'll call it "What's That Hashtag?" And so, in this case, I think for this show, it's hashtag Hadoop, hashtag HDFS, big data, cybersecurity, Hyper-V.
Big data with a...
Yeah, and you start to see the more you rattle on that there's just a lot of stuff at play, and we're gonna get down to the core now that this is up in operation. So make sure you go out and read those articles so that you can keep following along. And next week we're probably gonna spin back while we start bringing up our first data set. So we might shift gears a little bit, but that'll give you a chance to catch up with us and us a chance to catch up with ourselves. And then we'll start taking a deep dive into that data. And we're also hoping to have a guest on here in 2 weeks. We're still finalizing that, so stay tuned. And you can now get information about all these topics from my Twitter feed as well, which is growing at a very fast rate.
Don't rub it in, Christian. Don't rub it in.
Jim is a little jealous, but I've told Jim...
Wait a minute. Hold on. You putting that on me. I never said I was jealous.
It's okay. You don't have to admit it. But
Christian's telling me about how he found the secret sauce for...
allegedly. Yeah, allegedly.
But the secret sauce is running, and it's starting to kind of just become... I pretty much at this point tweet all on cybersecurity and big data, so it's almost like reading an annotated footnotes of what I read every day and what you would see on this podcast and on Cyber Frontiers. So that's a follow at TheWizBM, TheWizBM, and I'll likely follow back, and that's another way to syndicate content.
Ashton, are you using Twitter much? I know you weren't using it.
I have one. That's it. I don't use it. I may in the future, but for now, if you follow it, you will receive probably nothing.
Okay. All right. Well, good to know. As I put the show notes together, you know, I type your name, and typically or traditionally we always put your Twitter account after the name.
Maybe in the future. I mean, I have a lot of stuff
that
I could post, so I don't know why I don't. It hasn't. Yeah. It's not something I do.
Hey,
I guess it's not a habit.
Yeah, it's fine. Don't worry about it. You'll get there eventually. Christian will get you all hooked up with the code that makes it all automatic.
Oh,
So,
yeah.
Awesome sauce. It's called the awesome sauce.
it's pretty good. Hey, let me ask you guys this. So, ShellShock, from the average guy standpoint, from my standpoint, what do I need to be worried about? I mean, what it seemed with, Heartbleed, I had to go out and change everything, and so from the average guy perspective, what do I need to do now?
As an average guy, if you're running Windows, this conversation isn't relevant to you. If you're running, yeah, right. Windows actually, for once, is not the center of attention for some flaw. So Windows for the win.
Well, it really wasn't for Heartbleed either, to be honest.
Oh yeah, no, I'm just saying in general, they've had some other interesting.
Heartbleed affected all my online accounts, right? I had to go out and change everything to get it.
Right.
Do I need to do that on this too?
Well, so the big things here are, like, for example, if you're using AWS that has any type of Linux distro, make sure you run your upgrades and updates. If you are on shared hosting, make sure you see some article from your hosting provider that they've patched these systems, or give them a call and ask them. I also tweeted this week a little small test that you can run to see if your terminal has the vulnerability, so you can run that and read that. And again, really, unless you're in the web hosting space or anything Linux, those are the only people that should worry. Mac people, I hear a lot of back and forth on Mac is vulnerable, Mac is not vulnerable. No, it really is. Mac has released an upgrade. It's not life or death if you don't patch it on your laptop that's running Mac right away. So have no fear. But
it's not really a web server, right?
Yeah,
right.
When it's mostly the public-facing IP addresses you need to worry about. Your laptop isn't sitting on that
right.
reachable
So,
network.
Unless you're at the University of Maryland.
Yeah, in which case maybe.
Yep.
Sometimes.
Yep.
Okay, well, good to know. Anything else? We are at we're just a little bit over an hour. Anything else that we want to cover before we wrap this up?
No, I think that's a wrap.
Ashton, anything you want to cover before we wrap?
I don't have any more
What?
burning insight to provide you. I'm sorry.
Wow, that's it. We're at the end of the internet.
Yep.
The end of the
Covered
internet.
everything I know. I have nothing else for you.
We have nothing else to say. All right. Well, so you mentioned some guests potentially coming up for. Would that be for number 10?
That's the Big Ten.
It's in the works, yeah.
That's the Big 10, and we are right now shooting for the next show to be the 13th of October.
Are we going back to 9 p.m.?
Yeah, we go back to the regular time. I think.
Okay. 9. Well, depends where you are, I guess.
Right.
9 p.m. Eastern time.
9 p.m. Yeah, 8 p.m. Central, 9 Eastern will be the normal time. I was just going to take a peek here and see what.
I'm actually kind of surprised at how well Christian's held up at the later time frame. Usually a little bit.
know. Good, isn't it?
Usually he's put himself to bed by now. I mean, when you have dinner at Denny's at 3:30.
Something like that.
Well, we'll remind folks that we do this every 2 weeks, and if you haven't subscribed to this yet, we've got lots of different ways for you to subscribe. Maybe you came in, maybe you found Christian on Twitter, and you're listening to this for the first time, and you're like, man, how do I get more of this goodness? How do I do it? Well, there's lots of goodness available, even in the back episodes. Head over to theaverageguy.tv/subscribe, and we have all the subscription links available out there for you. You can do it on iTunes. You can do it through an RSS feed. We do have video large and small. We want to thank MediaFire. They're hosting that for us and providing all the bandwidth to make that happen. And those are brand new feeds for you. So you can download that to your phone, watch this, from the passenger seat in the car if you want to do it, or on the bus, or on the train, or in a plane, or in a car, or in a boat. You can do that as well. We also want to remind you, if you'd like to support the podcast in some way, you can use our Amazon affiliate link, so theaverageguy.tv/Amazon, or if you live in Canada, theaverageguy.tv/AmazonCA for Canada. And John, I just checked in with John, and those benefit him, John Zadler, in Canada. He's kind of our hacker tester guy in Canada. And there was a few purchases on there, so you Canadians, you need to step it up a little bit if you're going to purchase from Amazon. You can only use the CA one in Canada. U.S. people, don't use the CA one because that doesn't work. You can't buy things in Canada. You have to buy them here in the United States. Thank you, NAFTA, for all that. We'll be back here 2 Monday nights from now, 8 p.m. Central, 9 Eastern, out at theaverageguy.tv live. We want to thank you for watching us live and for listening to the download as well. And we will say good night.